Hello there, this is Daniele from Toolchefs, and in this video we're going to have a look at how you can build a more complex scenes than the ones that we saw earlier in the other videos. In this scene, as you can see, there are some nice elements, such as we have archers, we have soldiers practicing, also we have like very simple interactions between soldiers based on proximity and area triggers. We have also a couple of formations. We're going to use caches, different type of layouts, and we're gonna also make a render in the end. We're also gonna use the new feature of the Alembic Reader for basically populating, creating some trees. So you see a couple on the screen, and just a couple just because they were too big. And finally we're gonna render. So I hope you're gonna like this tutorial, and let's go. So first thing, we need some assets. We're gonna use this character from Mixamo, so you'll have to download the paladin with the sword and the shield. And just click download. Of course, you have to be signed in and download the FBX. I've already done it, and they're all already on my machine. Then you need to. We're gonna also use some animations. And the first one is gonna be the block idle. So it's this one, sword and shield block idle. Then we're gonna use the standard idle, which is the second once you search using these keywords. Second clip. We're gonna use the slash as well, which is this one, sword and shield slash. Then the walk. The first clip here, sword and shield walk, and the two-hand sword combo. In here you see basically we have both the sword and the shield, but later in Atoms we're gonna remove the shield, so you have the actual animation with just the sword. So you need to download all of these animations, FBXs, and I've already created a new project, and I've placed them under a subfolder called FBX inside the data folder. So there are these ones here. Now I'm going to open Maya. Cool. And the first thing that you need to do with Maya is you need to load the FBX plugin if you don't have it already loaded. You do it via command line or with plugin manager, of course. I'm gonna import the FBX of the character. Make sure that it has been skinned, so I'm gonna click 6 to see the textures. I'm gonna do X-ray, and I'm gonna rotate the joints, one of the joints, and you see that it's skinned. So I'm gonna place all the geometries under one group, and I'm gonna call it skin. While you can leave the joints, the root joint at the root level here. Okay, so before you export a character to Atoms, you have to make sure that some of the joints of the rig are properly tagged. When I mean tagged, I mean just basically these joints need to have some Maya attributes with a certain name. So for tagging, we use the skeleton and animation exporter. So as you can see here, you have 5 different buttons. With the first one you tag pelvises, the second one you tag the root of the AK chains, the foot AK is actually where the AK handle is, the foot tip is the tip of the foot, and the skip AK instead is an attribute that tells Atoms to skip a certain joint when it evaluates the new IK for a leg, for instance. So if you have, for instance, a roll joint here, or another mid joint here, you might want to tag those mid joints with the skip IK tag. So first thing, I'm gonna tag the pelvis. And when I say tagging again, it's I just basically add these attributes. So if you can even add them with your own scripts, just make sure that the name is correct and the value is correct as well, so the initial value. Then I'm gonna tag the foot root, and as you can see, 2 annotations nodes have been created, and usually you can leave them there, but it's good practice to move them a bit forward. These are the pole vectors for the key for each leg, and even if you move them right to left, you see they're not actually affecting the skeleton here. This is just because this is the pole vector for the IK, the atom's IK, so it's not actually my IK. Just make sure that it's basically in a straight position from with the leg, basically. So over there is fine, basically. Okay, so that's done. We'll want to tag now the foot IKs and the foot tips. At any time, you can always double check what you have tagged by just clicking the select all foot roots, select all foot IKs, and so on. And you can also untag these joints if you want. Okay, so another thing that we need to do before continuing is that I just forgot to do, but we're gonna do it now. I'm gonna select all the joints from that are part of my skeleton. I'm gonna clear the animation, and also I'm gonna make sure that the rotations are all to 0. So if you see something weird in your rig when you set the rotation to 0, just make sure that your bind pose is set correctly and so on. So before, of course, exporting to atoms. So I'm gonna select the root joint, and I'm gonna set the bind pose attribute by clicking this button. If the rotation are not at 0, when you click this button, you'll see an error popping up here. And again, like, you need to have rotations at 0 before you set the bind pose attributes. This is fundamental for atoms to evaluate the pose correctly later. So just always remember to click that button. And if you change your skeleton, you have to click it again. So because the bind pose attributes would have changed. Okay, so now I'm going to select the skin group. I don't have any proxy geometry, so I'm not gonna provide any geos group. And now I'm gonna go here, configs, soldier. Sorry, there's a typo there. Soldier. Once that is done, I'm all happy. I'm gonna click export, and the files have been exported correctly. Before we continue, I'm gonna save this scene because we're gonna use it later. I'm gonna call it soldier rig, and I'm also gonna save it as another scene because we are gonna use it for exporting our animations. So first thing that we're going to do is basically we're gonna start importing these FBXs on top of the scene. But if you, this is the way you work with FBXs, but if you, for instance, have your animation on a rig, if the joints have been tagged properly, you can export the animation straight from the rig. But you again need to use this little UI here. So first one, I'm gonna use the block idle, and I'm gonna save this into the atoms FBX folder. Block idle. Let's call it soldier block idle, just so that we avoid any confusion. First thing that you need to provide also is the root joint. Again, if you have an extra joint, both for the skeleton and animation, you can add them here, and these are mainly prop joints. We don't have them here. We're not going to use any prop joint here. And we're gonna do, we need to provide a ground height. And basically you do it by selecting one of the foot tips and clicking the from selection button, and this is gonna basically get the word y value for this for the selection and store it here. So this is needed because when we export the FBXs, Atoms caches some data from the Maya scene onto the FBX. So in this case, when you provide a ground height value, atoms will make sure will store the foot down state on these joints. So on the foot tip joints, the ones that we tagged previously, using this value. So for instance, if the world y value for this joint is lower than the ground height plus threshold, that foot down state is going to be set to 1. Once the foot down goes higher to that height, you basically the foot is not down anymore, so that value that is stored inside the FBX is going to be set to 0. So it's always good practice if you have 2 feet to make sure that you pick up the one with the higher ground height. I'm going to use that one, and just going to use a low threshold. Also, when you export an FBX, you also export an animation clip file, because you can use both FBXs or atoms clip. We're going to use FBX here, but when you export an animation file, you also export a preview file if you have this checkbox on, and a preview file is just a play blast that is exported with the FBX, and it also contains some extra data that is used during when you scrub in the preview. I'm gonna hide these 2 pole vectors just because I don't want to see them in the play blast. I'm gonna turn off X-ray, and because we are gonna create a play blast now, it's always good practice to make sure that the character is inside the renderable area, so it's inside the screen basically. So I'm gonna click export, and now this has been exported. So the first one is done. I'm gonna export now the idle, and again is pretty much the same, so we check the one that is higher. So let's pick 0.5, and the feet are pretty much remaining the same all the time, so we're just gonna use that one. And I'm gonna yeah, that's fine. I'm gonna just press export block. No, this is not block idle, sorry. Always remind to change the name before clicking export, otherwise you overwrite what you've just done. Okay, we do the slash. For the slash, probably the feet I'm gonna change slightly. So let's see if they're moving. Yes, they are moving a little. So if they move, what you can do to make sure that you picked like a nice value, you can, let's do, no, sorry, X-ray, not X-ray joint. I'm gonna create a locator. I'm gonna place it here just as a reference. Actually, it was the other foot that we picked earlier, so this foot here. And we're gonna place it at 0.53. So there. And if you, so the animation here is pretty good when the foot is down, so we don't need to worry too much about it, because when it goes up, it's actually not in the down state, it's actually moving, the foot is actually moving. So yeah, so that probably we can just ignore it for now. So for this one, I'm just gonna leave the value to 0.5, and that's it. And I'm gonna keep the foot threshold at 0.3. Okay, export. It's good. Now we do the walk. So the walk is a bit trickier because we actually need to make sure that the feet are properly evaluated. But again, this is fixable later, so don't worry too much about it. So you see now the ground height is already at 1, which is already a difference from the other clips. So this is the foot. If I create again my magic locator and I move it here, if you press basically, if you scrub the timeline, you see the foot there is actually down because the character has all its weight on that foot, but it's moving because the FBX is not perfect. It's not as good as the other ones. So we can say that there is down. We can go up, check the locator value. It's around 4.2. So I'm gonna provide a threshold to 3.2. But because basically it's the difference from that value to that value, and plus I'm adding a little bit. Actually, that's 3.3. You notice that the other foot, so this guy here, the left foot, is actually at a lower value when it's up. So we'll have to fix. So quite surely the foot down data is gonna be stored incorrectly on the FBX, but we can fix it later, and we're gonna do that. Okay, so that's done. We're just gonna remove the X-ray. Okay, for whenever they're walking or they're doing something like running and so on, make sure they are the center of the screen, so you can see later in the preview the feet. I'm gonna click export. Cool. So this is done. Oh, I just overridden the slash. So let's go back. And always make sure, always make sure that all your fields are set properly. Okay, that's done. And now we do the combo. For the combo, I'm gonna pick that one. Because there is down. Okay, let's double check again with the locator. Yes, again with the locator. No, this one is pretty good. Okay, so I'm gonna leave it that for now to a low threshold. Okay, so that, and this is the combo. And I'm gonna click export, and this is exported. If you import FBXs, make sure that the keyframes are always at the integer values, because sometimes the FBXs they don't have the right frame rate, so the right FPS. So sometimes you see them being at basically having keyframes and not integer values. So always make sure that your frame rate is right for your clip. Okay, so now we've done this, and we can start with setting up the Atoms environment. So now we can start creating our agent types and animation clips. So you have to open the Atoms UI, and we're gonna create them in GUI mode and not in Python. So I'm gonna call it soldier. Gonna select the atom skeleton that I created previously and the skin. We don't have any proxy geometry because we didn't create it previously. I click register, or you can press Ctrl S and you save basically this agent type into Atoms. I'm gonna create now an animation clip. I'm gonna say idle. And I'm gonna go in the FBX idle, and as you can see here, as soon as you select an FBX or Atoms clip, the preview here will appear if basically it lives if there's a file with the same name of the FBX but just the extension is different. The extension is going to be TAR, so it's a tar file, and that contains the play blast and the information that is displaying here. Of course, if you didn't export one, you won't see it here. And also at the same time, if you register animation clips with Python, so you don't use the atoms UI. You will, even if you'll see them here, your animation clips, even though they will have a different icon, it will be red and blue. You won't be able to see any of these attributes or the preview. So just so that you know. First thing that we need to do is we need to set, so this is a loopable clip because the pose is pretty much the same. And the start frame is 0 and end frame is 76. So we're gonna change that. Just change the loop blend to 6, and I'm gonna set the direction type to static. So if you are unsure about the direction type, just go back to the documentation, but basically static is what you mostly use. Joints is when you have, and joints is when you have quadrupeds. But just for now, we're gonna use the static one. Okay, so then we say my compatible type agent is the soldier. Here you can also say provide some transition frames, which we're gonna do. Basically, if you click the auto button and if you provide the soldier, so the same agent type, and provide a tolerance, and you click compute, this will try to find the matching poses into this clip. But again, because I'm pretty sure that it's not gonna be none, because the clips here, because it's mock-up, basically the pose is different from frame to frame, and they're quite different, even though the difference is very little. But I mean, it's a substantial difference anyway. You can still, even if the auto button doesn't work, you can still type them in. So because the blending system in Atom is pretty good, you can even provide because here the clip again is not changing much, you can provide a lot of transition frames. So we can do like that, 50 and 60, like that. Basically, transition frames they're used with by the state machine, and when you type this value, this frame number is here, you are actually telling the state machine that it can change state even at one of these frames instead of waiting the end of the clip. So it's pretty useful. So okay, so now we save the first clip. I'm gonna now do the soldier block. Sorry, this one I'm gonna call it soldier idle. Okay, now I'm gonna go and block idle. Yeah, see now, so 0 and 42 is the end. So 0, 42, static, and that's it. I forgot to mention that usually when you select the static button, the static type, usually you would get your clip direction from this value here, but because here the pelvis is not moving, we don't see any difference. So here it's very hard to understand what the direction is. So if you have all your clips for the soldier being having the clip direction from the animation export to 0, 0, 0, you can just use the direction with 1, 0, 0, which is the x-axis. If you find any of the clips being having a direction, you are better off using that direction. So later we'll find it in the walk, and we're gonna come back here and change the direction if we need that, if you need to change it. Okay, now we're gonna okay, so that's done. Yeah, we go to the, we do soldier, the other was slash. Yeah, okay, so the slash goes 0 to 45. Okay, here again the direction is that we don't have any difference, because this is a loopable clip like the others, and the direction is evaluated by the difference of the basically the pelvis translation from the first and last value. Sorry, first and last frame. So because the pelvis goes back to its original position, we don't see any clip direction here, and that's why soldier, I think I forgot the block here to provide the soldier. Okay, so another one is we need to do the combo. Yeah, combo, like that. And here we have a direction which is, as you can see, it's moving on the z-axis. So this means that the direction, which is going to be static, it goes on the z. So you have to set it to 0, 0, 1. And same thing, now you have to go back and change it for all the other clips. Like that. Like that. Yep. Okay, so this is the soldier combo. The start frame is 0, the end frame is 98. Blend 5 is fine. Yeah, okay. Soldier, we don't provide any transition frame, that's fine. And now finally the last one is the soldier walk, which is gonna be the soldier walk FBX. So start frame is 0, end frame is 33. Yeah. Loop blend is fine, it's loopable, okay. Static, here again you see the clip direction is moving on the Z axis. So again here is 0, 0, 1, soldier. Okay, so now we have registered all of our animation clips, and now we're ready to test them in Atoms to see if they are behaving correctly. So what you do for testing, you create an agent group, you create a grid layout or any layout really, select your agent type. So first thing we need to check if the skeleton and the skins have been exported correctly. Here you see basically the texture of your agent is different from what you had in Maya earlier. This is because here we just see the diffuse, we don't see anything else, because that is the only thing that we export inside the skin geometry for an agent type. Then what you want to do is you can create an animation, sorry, a clip reader, sorry, and go in here and we're gonna test the clips. So soldier, idle, if I press play, yeah, looks pretty good. Soldier, block, yeah, slash. Now let's see. Yeah, that's good. The combo. So you see here the feet are behaving pretty much okay, but we have few pops. So you have two options here. So the first one, if you go back to so this one is the combo, so we go back to the combo. So the first thing that you can do is you can set it to idle clip. This is an idle clip anyway. With the idle clip you disable the foot lock system on the feet. So if we press play now, we won't see those pops anymore because the foot lock is not there. See? Okay. Otherwise, if you're brave enough, what you can do. Also, another thing, I mean, we can change. Now we're gonna try to fix the feet by disabling the idle state. But when you have small steps, it's always a bit tricky to get it completely right because there's very little variation. There's very little time for atoms to actually go from one state, from one foot position to the other. I forgot to explain about this after foot up. So basically, for instance, if you go to the walk, once the foot gets off the down state, we'll use 4 frames for blending from that position to the FBX position. So if you don't have enough frames from between one of the the 2 foot down state, you won't get nice results. So okay, so anyway, let's try with the combo. We do so we have to set the compatible agent type if you want to make if you want to change the foot down data here. And now we go and check what's wrong with our. So let's squeeze it a little bit. I'm gonna move it here. So there you see there's a big pop, first one, but also there's another one over there. So maybe we're just better off, you know, if we want to keep it. So that's the right foot. So you see it's always down there, which is actually also what you need to do is you need to set start frame to 0. So we actually need the exact start frame of the clip, because if you set it to -1, it will pick a random frame. So there we're actually at the first frame. You see it's the same frame here. So now okay, that is fine. Okay, so probably the best thing to do here is to don't use this foot down here. Just bring it down, and just those. Sorry, let's make it this a bit bigger because I need to see it. Okay, that 73. Yeah, it's already at the last position at 73. So this probably is gonna be good. So let's see. So this is, we just changed the left foot, I think. Is the left foot? Oh, no, sorry, we just changed the right foot, sorry. Yeah, much better now. Of course, we won't get any foot lock here, but we don't need it because the foot is actually moving. See there, that little step. And then for the left, it's gonna be probably the same. So there we don't need it. Probably just need a little bit at the beginning. Then here there's way too much foot down. Way too much foot down. I mean, now I've done it not perfectly. I just try to get it right with very little effort, but now it's much better, as you can see. The knees are bending a little bit unnaturally there because we have the foot locked, but I mean it's okay. It's not great, but it's okay. Again, if you don't want to use the foot lock, just use the idle state, and that will solve all your problems. Okay, so we're missing the last one, the walk. Sorry. So okay, wow, this is this doesn't look great at all, but we can fix it quite easily as well. So it's always a matter of just, so I'm selecting the walk. It's just a matter again here to set the agent type and just set properly the foot state for the feet. So frame 1, the foot down is the right foot. So you see there already the left foot is down, but it shouldn't be. So okay, there it's fine. So until frame 11, it looks like a bit too long. Yeah, you see, in fact, that pop there, that pop is because the foot has been down way too much. So probably, let's see, frame 8. Let's see if that is fixed. Yeah, it's a bit better. Let's remove another frame. Okay, then we go here. These frames shouldn't be down because it's where the foot is actually traveling, but it's going below the ground height that we provided earlier. Frame 26, no, it's down at frame 28 probably. So the right foot now should be fixed. Let's actually, let's also fix the left foot because it's disturbing. So so 12 is down, then it goes, okay, 12 is down and then it's going up at 26. Okay, save. Let's see if now, much better, much better. Looks good. Great. Okay, so the animation clips now are done. So next thing that we want to do is, because in our shot we're gonna have some soldiers walking and then slashing the swords, or we're gonna have them being in idle pose and then blocking. We need to build a very simple state machine. So you go in the state machine tab and you just provide a new name for your state machine. Once that is registered, you can also assign it to your soldier, which actually you have to do it because otherwise the state machine module won't work. And you can start creating states. So you create state by pressing this button or right clicking on the viewport and then selecting that add animation state from the menu. So this one is going to be my work state. The IDs for each state have to be different. So Atoms automatically assigns a unique value. If you change it, just make sure that you're actually providing a unique ID. So for the work state, we're going to use the soldier work. And then we want it to go to slash. So slash. And unfortunately, we don't have any transition clips because Mixamo doesn't provide them. So we're just going to have a straight transition. So for adding a transition, you just right click on top of one state and drag it and drop it on top of the another state. We're gonna have just a linear blend here, but again, like, we can't do much about it because we don't have any transition clip. If you don't have a transition, you won't be able to go from one state to another. So you always need to basically to say to Atoms, I need to go from this state to this other state. Then we need to have the idle and the block. So the idle and the block, like that. Oh yeah, okay, so then we can save it and we can use this state machine. You can also change the blend in frames and blend out frames. Let's just change them a little, because we don't have any transition clip. Probably it's good to provide higher values so we have a better transition, more frames, and we can test this out now. So remember always to assign the state machine to your agent type. If you're not familiar to state machines, a state machine is simply a graph where each node is called a state. Each state can contain several clips, and whenever an agent is in that state, it will play one of those clips. I mean, it also depends how you set up your state, because you can have it. We have different modes, so it can be merge, exclusive, or random. But again, this is sort of like a simplified explanation of how a state machine works. So now I'm gonna go back to my to my agent. I'm gonna remove the clip reader, and I'm going to add the state machine module. So when I click rewind, will be in the work state. So if now I press play, will be in the work state because the state is 0 and the work ID here is 0. Okay, so this is very important. This state here is matching the ID value here. So if I would set 1, it would be slashing, which I'm gonna do in a second. So if I now press play, you see it's just working. If I set it to 1, it's slashing. If I set it to 2, it's gonna be in idle. If I set it to 3, it's gonna be in blocking pause. So super cool. It's important to know that all these attributes that you see here, they are nicely wrapped in this UI, so you can edit, you have menus, and you can override the per agent, the state, or anyway the values that have this button. But all of these are just my attributes. So even the state, if you open the extra attributes section, you will find it somewhere. So we can look for it now. Yeah, see it's here, atom state machine state. So it's this one. This means that you can actually work with these values as they were normal my attributes. So you can create animations, you can connect, create connections, and so on. In fact, here what we want to do is from the work state. So I'm gonna click rewind. Work state. We want to go from the work state to, say, a frame 16. It's whenever you set the state, make sure that the change happens in just one frame. So here, that's why I set it again to 0 and then to 1. So from the work, we're gonna go to the slash state, like that. And you see actually there the foot didn't look nice at all because that was in locked state. So probably we can go back to the animation clip and let's see if by setting the slash to idle, if that fixes. Yeah, it's much better. So we're just gonna keep the slash to idle just because anyway it's in the same position and we don't really need to have the foot lock for that clip. Okay, so sorry. Now we try instead so we remove the animation. We go back to frame 1 and we set the state to 2. We set a keyframe, another keyframe, and set it to 3. And now we block. You see, so we went from idle to block because the movement was so sudden, was very quick. I'm just gonna increase the blend in and blend out frames. So now it's 8 and 8. But probably it's gonna be a bit. Yeah, it's a bit better like that. Cool. That's great. So now we are all done with this state machine. I forgot to test my last clip, which was the combo. Or maybe I did, but I forgot. So cool. Yeah, it's working fine. Okay, so now we're all done. We're gonna save this scene. I'm gonna save it to, you might have even saved it earlier because I was quite brave to just leave it open for that long, making all those changes. So I'm gonna save it so I can always go back to this scene if I need to. But before that, before creating a new scene, I want to export this JSON file. So basically the scene JSON is the content of the Atoms UI. So the Atoms UI has all this stuff, so all your animation clips, the agent types, definitions, blah blah, behavior modules that you might have, and so on. By exporting the scene JSON, you're actually exporting the content of that is represented by the Atoms UI here. This is useful because you might want to use the same setup, so the animation clips the agent types in another scene, and you can import it there. So I'm gonna go to data, JSON, and I'm gonna call it soldier. So there you see already I have another JSON file which I exported from the scene that was created by we created in another tutorial, which was the arrow emitter tutorial, and I'm gonna use that one as well in the later on in my scene. Soldier, it's exported. That's cool. New scene. Actually, before we continue, I'm also gonna export this tree. Basically, I downloaded it from the internet. It's just a very basic tree, and I already scaled it so that it's basically big enough for my scene. So it's relative to the soldier. Whenever you use one model that is downloaded from the internet, please make sure to clean up the mesh. So like really clean it up with everything, so you remove any degenerated polygon or things like that, and also make sure that you have valid UVs. So this tree that I downloaded had proper UVs, but the geometry wasn't good enough, so I had problems later. But anyway, so with this tree, what I'm gonna do is I'm gonna export an Alembic. So I'm gonna import load the ABC export plugin. Again, you can do it from the plugin manager if you want that. And I'm going to do export. Sorry, first I have to select it. Then I'm gonna do cache, Alembic cache, export selection to Alembic. I'm going to export the current frame. Then you have to go in the attribute prefix and provide atoms underscore and AI as prefixes. AI is for Arnold, the atoms underscore is for atoms. Then make sure to write the UVs and the UV sets. Click apply. I'm gonna save it here, and we're gonna use this later for populating our scene. Okay, so now we can import the JSON file that we just exported, and it's gonna be soldier, and afterwards we're gonna merge the archer one. So when you import, basically the content of the JSON that you're importing is gonna be substituting whatever JSON file that you have in your scene, while when you merge, the content of this JSON that you're selecting is gonna be merged with the content of the JSON file that you have in your scene. So basically with the import you override whatever you have in your scene, with merge you combine them together. So now I'm merging the archer. So if I open now the Atoms UI, you'll see that we have archer clips, soldier clips, and so on. Also the agent types and the soldier state machine. So first thing that we're gonna do, we're gonna start by creating a plane. Actually, let me first create an agent group with my soldier. It's just so I can keep it as a reference, because you see the plane, the default plane size is quite small, so I'm gonna just make it very, very big. That. Okay. I'm just gonna change some attributes of the camera. Then the plane, I would like to change its subdivisions, something like that. And afterwards we're gonna just modify it a little. So let's make this bigger, something like this. And this doesn't have to be accurate. I mean, you can do it just some rough deformation here. If you want it to be accurate, you can do it accurately, but I'm not gonna do it right now. So so this is done now. I'm gonna add it to the height field manager. So I'm gonna register this mesh as an height field. Let's call it ground. So add, I'm gonna call it ground even here, and I'm gonna select the mesh. Don't click on animated because our ground is not gonna be animated. Of course, if you have an animated ground, you can click it, but just remember that whenever you have an height field that is animated, then basically at every frame, Atom is gonna rebuild the internal structure of the height field, and that could be quite heavy. So okay, so let's also assign a simple shader. So let's create a Lambert green like this, and I can select this guy, assign material. Actually, let's make it a bit brighter because it's a bit dark. Okay, something like that. Cool. So I'm gonna save this scene straight away, and I'm gonna call it training scene. Another thing that I want to do is to create a camera, but first let's actually build our first group of agents. So I'm gonna select a state machine, and I'm gonna set the state to 0, which is the walk. But now you see that the agent is walking below ground. So to make that walk, to make the agent walk on the ground, you have to select the height field here. So ground, and now it's walking. I'm also gonna change the display type to skin, so I can actually see its skin. I'm gonna press 6 to see the textures, and now it's walking on the ground. Cool. Okay, so now what we're gonna do is we're gonna create a bit more agents. So let's say we want to do a 10, 5, something like that, and actually let's do 5, 10, 10, and change the direction. So I want them to go this way, so they're gonna go in the -z axis like that. I'm gonna move them here. As soon as you click rewind, you'll see them being back on the ground. So okay, so that's done. I'm gonna create also a camera. I'm gonna look through it. So camera, before I do anything, I'm gonna change these values as well. Okay, so okay, so I'd like my camera to be like this. Let's do it a bit wider. Okay, something like this. Okay. And what I'm gonna do next, I'm gonna lock the camera, so I'm not gonna mess it up in any way. Lock selected, render camera. Okay, so and then I'm gonna save again this scene, and I'm gonna just increment and save. Actually, let's change something here. Something like that. Increment and save. Okay, so that's cool. So let's look back through the camera. Cool. Okay, so now we are having basically an initial setup. So what we want to do is to have some agents working here. We would like some archers here practicing, some other fighting here, and other agents here like practicing with their sword and so on. After that, we're gonna build variations, and then we can render with Arnold. Okay, so first thing that we're going to do is I would like to have more agents here. So instead of creating a new duplicate in this group, because you could do it with the duplicate button in the shelf, I'm gonna actually use a different approach. So I'm gonna cache it out. I'm gonna cache this group out. So let's go in the cache, Atoms cache. I think I have one already here. Yeah, I used this one before for a test. I'm gonna also change, the frame range here to 300, just because I'm pretty sure that we want some more frames later. So in frame 300, and I'm gonna replace this agent group with an agent group, new agent group with a cache reader module. So this is now caching, it's writing out the files. Okay, so and as you can see here, my original group is hidden now. I have a new group with a cache reader which is reading the cache that I've just exported. Plus, I have also display tab set to skeleton. I'm gonna change it to skin so I can see them back again. So apparently nothing has changed, but this is because the cache that we're reading is actually just matching whatever we had simulated before. So if I now I show these the old agent group, it will actually match the simulation. So what I want to do is I want to get this cache and move it behind, something like that. But if I press rewind, you'll see, so let's go back to the perspective, you'll see that they are actually floating, they're not on the ground. And this is because with the cache reader you also have to apply an height field. So it's going to be the same height field that we're using for the main, the other agent group. So if now I press play, they are they're walking basically. So, and if I look through the render camera, you see they're like that. One thing that I would like to do though is for the cache, I would like some agents that are in this formation here to go this way. So I just would like them to turn and go this way instead of following the others. So to do that, we're gonna create a couple of curves. So the first one is just gonna be a straight curve, okay? So I'm gonna first select the mesh and I'm gonna make it live. And then I'm gonna go into curves. And the first one, I'm just gonna make 2 points like that, just a straight line. And then, so this one I'm gonna call it straight line. And then another one, which is gonna start from here. I'm just gonna go this way, like this, okay? Cool, so I'm gonna turn this off. And I'm also gonna create a new plane. So again, I'm gonna move it up, make it bigger because it's too small to see. Move it here, down, and here we are. Okay, so let's actually move it here because I just want these agents to turn. Okay, something like this. I'm gonna also, I don't need that many subdivisions, so I'm just gonna do 3 by 3. And so for this agent group, what we need to do is we need to play a little bit with modules. So we're going to actually, let's first rename, sorry, this curve. Curve is a good name. So let's go back to the agent group. So first, what we basically, if we press play here, the agents are still going through. If now I, for instance, create a follow curve module, and I assign the curve, so the one that is actually curving, and if I press play, you'll see that the agents are not actually following the curve. This is because they have these options, this option on. So the direction from cache option means that the cache direction, so the direction which is cached inside the cache files, is always going to be used for driving the agents. So even if I press play and I have a follow curve, that's not going to work. If I uncheck it, all of them are just going to follow the curve from the beginning, which is not what I want basically. I could basically animate the values for the agents. So for instance, if I select some agents with the agent selection tool, do this, you see that basically here the selection is getting updated. I can set the value just for the direction from cache here, and that is basically not, false not for now these agents. And also you see that these are turned green. This is because we have some overrides. But if I press play again, they are following the curve straight from the beginning, and I don't want that, okay? So let's forget about this direction from cache at the moment. Actually, we're gonna use it in another way. So we're gonna still use it, but we're gonna play a little bit with the setup. So first of all, we clear the overrides, so we don't have overrides anymore. So I press play, they're still going through. What I want to do now, actually, let me select them back because I didn't want to unselect them. I want to create an area trigger and use the plane. This one I'm gonna call it area trigger, like that. Area trigger, here we are. And what we're going to do with this one is that we're gonna say whenever an agent is getting it into the area trigger, I want to change the follow curve weight, and the curve weight for this value basically is gonna be for this curve, sorry, is gonna be 1. So it's a double because the curve weight is a double. You can also check the documentation if you are changing a metadata from an attribute of these modules. You can check the type. So in here it's gonna be a double, and also we want some blending frames, so let's say 10, so it looks nice. If I press play now, again, it's not working because the direction from cache is on. If I turn it off and press play, all of them are still going through, just because the curve weight has to be 0, like that. Okay. So because we're not getting the cache direction anymore, they're getting just the default direction, which is the X, and they're just going this other way, which is not what we want. So to avoid that, we are going to create a follow curve, and I'm gonna just move it up here, and we're gonna use the straight line, and the curve weight is gonna be set to 1. So now, as you can see, these agents are curving, and these other one are just going straight. These one are curving because they're going into the area trigger. But as you can see, they're not completely following this curve, and this is because they are blending basically these two curves. So they're both following this curve and the other straight curve. So basically what we're getting is basically an average. And we don't want that, so to fix that, I'm gonna create a new area trigger. So under metadata area trigger, and I'm gonna again gonna set the area trigger here. And here, what I want to do is I want to change the follow curve 1, curve weight. So at the moment it's 1 for all of them, but I want it to become so it's a double, value 0. I want it to become 0. So afterwards, now you see that they are actually following the curve. So finally we managed to get the result that we want. Super cool. So I'm gonna hide the area trigger because we don't need to see that anymore, and also I'm going to clear the selection, and I'm gonna look once again to the camera. So now you see those agents are just going that other way. Let's increment and save. Cool. Now what we would like to do is also have some like a new formation here of agents, just doing the combo with the sword. So I'm gonna create a new agent group, and just gonna actually, let's give it some proper names here. Formation 1, formation 2. Okay, and let me actually, let's leave it this way. Cool. So now what we want to do is we want to the combo, we want to do a grid layout, we want to apply an animation, clip reader, it's gonna be the soldier, clip reader is going to be the soldier slash. Okay, let's move it to skin, and we want clip reader want to set the height field as well. So if now I press play, and actually it's not the slash, sorry, it's the combo, right? Okay, so we want just a lot of them, just quite a few agents, so let's say 100. Something like that. We want them to be some more random space, so let's say 20, 20, even though I don't think it's gonna be enough. 40, maybe 40, yeah, better. And let's change the space, maybe 300. That's too much. Let's play with these values together. Okay, yeah, come on, this is not that bad. Okay, cool. So W, we move them here. So while those agents are walking, these other guys are just, you know, throwing their swords around and probably almost killing each other, but we don't care that much. Let's actually be merciful and decrease the number of them. So let's say 8, and let's just change the X so that they're a bit more spread out, something like this. Okay, hopefully they're not gonna kill each other over there. Great. Now I'm gonna save an increment. Cool. Okay, now what we want to do is we want to have like a line of agents here and another one here, and the one here, the line of agents here is gonna walk towards the other one, and they're gonna you know, sort of like interact. So first of all, I'm gonna create just to change things a little, I'm gonna use a different layout system. So I'm gonna use a curve layout. I'm gonna make this live, and just for a second I'm gonna make it from shaded curve, something like this. Okay, cool. So now I want to make a new agent group. This one I'm gonna call it curve layout, and I'm going to create a curve layout. Gonna assign the curve layout soldier. I want also to attach a state machine with a ground, and I want to be in state 2, which is the idle state. And I'm gonna change the skin. Cool. So if now I'm gonna remove the wireframe on shader because I don't need that anymore. Let's go back to use the perspective camera. And if I press play, you see that they should be facing the other direction, but they're actually facing the curve direction. This is because in the curve layout you see there is this direction type, and I'm sorry if it's just an integer value. This should be displayed better, but basically if you check the documentation, there are 3 possible values here. So 0 means that their direction is the tangent, is tangent to the curve. If you set it to 1, it's normal, so they will be facing the normal, so it's actually the right direction. Or you can use a custom direction by pressing 2, like this, and basically it's getting this direction here, which is the one that we wanted. So yeah, basically this is the layout for the first agents. Now I want to create another one here. Actually, let's have less agents, something like that, because otherwise there would be too many. Okay, so now I'm gonna create a new agent group, and once again I'm gonna use the grid layout. I'm gonna create 5 agents, on the Z direction. And there's gonna just be spread a little bit. No, wrong value, something like that. Let me first change the animation to state machine, and then I'm gonna change the state to from 0 to 0. So ground, here they are. They would be sorry, this is the robot, it's not the soldier. Okay, I want them to go in the other way, so this should be -1. Cool. Now they are too spread out. Let's go back to 300. Let's see. Still way too spread out. Probably would have been a better idea to just to use a grid layout there as well, because now it's hard to match them. But let's see from the top actually. Okay, I need this to be a bit wider, just a tiny bit. 70, 80, 90. Come on. Let's go back to 300 and let's stop there. Okay, we don't want to waste all day just to align these guys. Cool. Okay, so this is done. So let them start a bit from behind like this. Cool, so let's say that when they reach this point, we want them to go into the slash clip. That we're gonna play a little bit with this, because probably it's not gonna be perfect on the first occasion. So let's make this a bit bigger. Something like this. Okay, and we are going to again change the subdivisions. Then this one is going to be called slash area trigger slash group block group. Okay. So basically what we want to do is that when they're gonna get into their trigger, we want to change state. So they're gonna go into the state where they start slashing their sword. So it's gonna be metadata area trigger, mesh is gonna be the slash area trigger, while the we're gonna change the state, and the new state, which is an integer, is gonna be 1. So now press play. Hopefully they will start slashing their sword. Yeah, here they are. And if you want to make this a bit sooner, the slashing a bit sooner, you can just change the move their trigger on the x-axis a little bit. But I'm actually happy with that basically. So here now instead we want them to go in a blocking position. So we're going to use a different module, because they are still and they're not moving, so they can't actually go in the area trigger. What you could do is to move another area trigger in order to trigger their state or animate it, but we want to use a proximity metadata module. So I want to use the slash group. Actually, first I need to create one. It's gonna be the slash group. I'm gonna close this one, and I want to change the state. I don't want to copy the metadata. I want to set a an integer value, and I want to change that to the blocking, which was number 3. So here I'm gonna activate the debug mode, so I can see actually, so you see basically this is the distance, the radius. So whenever another agent of an agent type, any agent type is gonna get into this circle, they're gonna change state in this case because we are changing just the state, but the circle is too small, so we need to make it a bit bigger, so probably 400, let's see. Maybe a little bit, something 350. Okay, 350 looks good. You can also filter agent types, like you can provide a list here, but at the moment we don't care because we just have one. I'm gonna remove the debug. So if I press play now, yeah, so they're blocking while the others are getting close. And of course this simulation could be done better. You could actually tweak, actually probably it would be best just to tweak the state manually for these guys so they get close enough, and when they are smashing, then you can also animate the or activate in another way the another state where they will actually react as they were actually being hit. So at the moment, of course, this is not, it's not perfect, but it's good enough for now. I'm gonna hide that. I'm gonna go show the render camera. If I press play, here they are. And I'm gonna save and increment my scene. Okay, now let's start with the archers. First thing I'm gonna do, I'm gonna create a cube. Let's modify it from here. So I'm gonna say 400 each, and just for the X, I'm gonna say 200. Move it here. Okay. Great, so keyframe. Something like that. Is cool. Let's move it like that. And now I'm gonna assign a new Lambert, something like this, to the cube. Great. Now I'm gonna create a new agent group, and I'm going to use the points layout this time, and I'm going to animation, clip reader, and I'm gonna use the archer draw, and also assign the height field ground. Now I can go to the points layout. I'm gonna use the skin mode, of course. Agents layout tool. I'm gonna select the archer. The archer is selected. I'm gonna put one here, one there, one there, one there, one here. This character wasn't set up completely properly, so the direction is not totally aligned with actual direction of the agent. So I'm gonna select them all. I'm just gonna turn them a little, something like this, so they actually face the cube. Okay, so it's now done. So the agents are there. Now I press play. They will be throwing their arrows. And in render camera, yeah, we're in render camera, cool. Great, okay. So this is good. We just need to throw the arrows now. So these are the archers. I'm gonna create a new agent group. And these are gonna be arrows. I'm gonna use an arrow emitter, of course. And now I need to first I need to select the agent group that is creating the arrows. I need to select the arrow agent type because this is the agent type that are gonna be generated. The default basically the metadata that is being used by the tutorial where the archers were used was called constrain arrow. And the direction axis was like this, fine, like this, and the emit arrow is the name of the trigger metadata name. Height field, we need to set this one as a height field, so I'm gonna say height field manager. I'm gonna call it cube. Actually, let's call it target. Select, and this is animated. Okay. So that's fine, that's all fine. Now the joint ID, this is very important because we need to provide a valid joint ID for the arrow, for the archer. So this is basically the joint that is generating the arrow. You probably remember in that tutorial that the number is 67, but anyway, if you want to know, basically the joint that is generating the arrow is an extra joint. If you want to know which one, is the only extra joint actually of the archer. So you can go in the animation clip events. There is this quick dirty trick, but you can select joints. You can select this button. This one shows you all the IDs for each joint. And I'm gonna select the archer, and if I go down here is the extra one joint, so 67. So anyway, you need to know first the name, and then you need to get the ID. So I'm gonna just set back to static. So this is gonna be 67. I also need here to set the height field, which was target. So if now I press play, actually let's set the multiplier, the velocity multiplier a bit higher. So actually, I need to change this to skin because skeleton is just one joint, so we won't be able to see it. So sorry guys, I forgot to turn on the use joint metadata. If now I need to make this a bit bigger, and but now if I press play, the arrows will be generated and they will get attached to the, actually probably I need this to be a bit higher as well, so something like this. So here we are. Cool. So this is done now. Render camera. This is great. So we have the arrows, we have all the agents fighting, practicing, and so on. So I'm gonna increment and save. For our last touch, we're gonna just add a couple of trees. I think the model I picked is a bit too big, so we're just gonna place literally a couple. So I'm gonna pick up the alembic, If you don't provide a skeleton, a skeleton with just one joint is going to be added. So basically that's going to be used. So then I'm going to create an agent group, call it trees. I'm gonna go to the attribute editor. I'm gonna do points layout. I'm gonna set this one to skin. Make sure to have tree selected here, and also to have a use height field. And then we're gonna place some trees. So we're gonna probably put one here, one here, and one not there because it's too big. Just one here. Probably if we would have picked a different tree, probably would have put more. But if I put them in here, you see they're actually blocking the view. So let's put one here just to add some vegetations. But that's pretty much it. Okay, so we're done there. We're going to increment and save. So this is how you can build your scenes, and it's very easy. Just now for this tutorial, we're going to also have a look at how you can export some variations and how you can apply them on your scene and render. But we're just gonna do it for the warriors. Not gonna do for all of the other characters. But if you want to do that as an exercise, you can do it. Some practice, to learn the software better. So yeah, so let's go back to the warrior scene. So it would be the rig. Okay, now we're gonna export some variations for our character. I'm gonna hide the two annotation nodes, and I'm gonna open the render setup layer window. As you might know, basically for exporting variations to atoms, we use render layers in Maya, and in Houdini we use stakes. If you know Python, you can use our APIs, and you can even check the variation builder code, which is gonna give you an understanding of how you can export variations. But again, if you don't know scripting, you need to stuck with the render layers for now, and this is the workflow that you need to follow. So each render layer is going to be exported as a different variation. So this one is going to be sword and shield, and in here you can create collections and add all the geometries that you want to have in that variation. You can add a material override for each item, for the items that are in this collection, and you can assign a material. If you drag and drop, always remember to press enter, because otherwise it loses the assignment to the material. Here I'm gonna just have a sword, so it's gonna be a collection with everything but the shield. Oops. Middle mouse button. And now we're gonna create a material override, and it's gonna have the same value as the other one, because we have just one material. So again, the sword variation will have just the sword, the sword and shield is gonna have both. So okay, so now we are ready to export our variations. Variation builder, you provide an agent type, which is the agent type that you're going to use in your simulation scene. So soldier is the one that we used previously. Variations, I'm going to save it here as soldier. Skeleton file is going to be the config that we exported previously. Skeleton root, it's this one. We're going to use Arnold. We don't need to do the simple material conversion because we're gonna just work in Maya, but just in case you want to export your materials and have them in Houdini, you should use this one, because we try to convert the Maya nodes to Arnold nodes. We're gonna use bake textures and create thumbnails. Create thumbnails creates like a preview for the variations to be seen in the variation manager, and it's gonna be a play blast, so of the current camera. So I'm gonna press run. the variation were built successfully. So now we can go back to our simulation scene. Click rewind. And now in this scene, we're going to import the variation JSON that we just exported. So the soldier. If you checked in the variation manager, you will find the soldier. These are the geometries that we have. The material, so we have just one, and these are the two variations. Sorry for the preview, I didn't place the camera correctly, but you can place it correctly so you have a decent preview here. So now I'm going to assign the variation, so it's gonna be these guys. So the formation one is gonna have, so I'm gonna go attribute editor, variations. Actually, let's use the variation randomizer, even though I have just one variation. So I want the formation one shape with the sword and shield. Run. Okay. Then I want formation two shape with the sword and shield. Done. Then I want the combo shape with just the sword, because they are the ones that are actually adjusting just the sword and not the shield. And then I'm going to select the so they are the slash group, sword and shield, and finally the block group with the sword and shield. Again, so the only ones that are using the shield only variation is this group. If you know the name, you can directly type it in instead of going to the variation randomizer and do all that stuff that I just did, but just to show you how that thing works. If you want to see the variations, you can just go here, and now basically that is displaying the variations. You can actually see it better in the combo group, because that one is going to have just the sword, as you can see now. The shields have disappeared. And here the textures look different because we baked the texture, so it's gonna be a bit darker. So I'm gonna select even this group and say variations, and then also formation 2 is gonna be variations. So if I press play, and also I'm missing the slash group, is gonna be variations, and we like that. Cool. So before we can render, we need to export all of this stuff in a single cache. So I'm gonna open the cache exporter, or multiple caches, but I'm just gonna make one just for the sake of simplicity. So slash group formation, the combo block, and that's it. So these guys, I'm gonna do a cache which is gonna be called atoms cache. I'm gonna call it final cache, and I'm gonna call it cache, and then I want to replace it with an atoms proxy. I'll click export. Done. So all of these have been substituted with an atoms proxy node, which is a lightweight representation of your simulation. Default visualization mode is in bounding box, so we want to see the variations. Here they are. If you press play, here is your simulation. This is also much faster than having an atoms group with a cache reader, because we are just accessing the simulation from disk and just visualizing it. We're not doing anything else. With the group agent group, you always do something else. So in here you can do a bunch of other things, but we're not gonna go. We have already seen some of these attributes in other tutorials, and we're gonna see the new features such as the instances and frost and calling in another tutorial. So now that we are here, we can just increment and save. And first of all, let me load Arnold. Okay, I'm gonna create a new light. Like that. I'm gonna change the exposure, something like that. So render settings, Arnold, renderable camera, render camera, and render. So sorry, the render view went on the others, on my other desktop, but I'm gonna show you in a second as soon as it's finished. So here you see the render, the trees and the archers are green just because they didn't have any material assigned, but the soldiers, sorry, they have the materials that we assigned to them, and also you see on the background that the combo soldiers, they just have the sword. So yeah, this is pretty much it. Hopefully you like this tutorial and explained, answered some of your questions. And sorry if it took this long, and probably at the end I completely lost track and I started saying nonsense things, but hopefully this was helpful to you, and I hope to see you in the next tutorial. Thank you very much. Bye bye.